this video, we are going to be learning how to determine the refractive index of a glass using experimental method or graphical method. Because why I said graphical, because we are going to be plotting the graph after the experiment. When we get the experiment done, we then plot the graph. I have my pencil, I have my protractor, I have my ruler, and I also have my pins. I have my pins I'm going to be using for this very experiment. So the first thing you do if you are to carry out this experiment is to trace. I'm not going to do the experiment in full. I will just show maybe this one, show you how to do it. Then I will bring already existing table that I've plotted so that I can redeem time. So what you do in the experiment is to trace this your triangular prism. This is our rectangular prism. This is our prism, glass prism. We trace it. Trace it. This is the prism. Then the next thing we do, we remove it and get our normal. Then the next thing is that the first angle I'm going to use here, which is likely to be the last one, because like I told you, I want to pay attention to the graph. This will take so much time, so we just want to show this one. We'll continue in this graph. I will also show you how to determine your scale, the easiest method of getting the scale done. So that's why I want to pay attention to that more in that area. So I have my 20, the sign incident ray, which is 20. Mathematical I is equal to what? 20 degree. 20 degree. So now I will put the pins. This pin will help us to trace the ray of light that's passing through it. So I'll replace the glass prism there. Then I will view I'll make sure I get it to where they are aligned together. Make sure you get it to the point where they are together in a straight line. In a straight line with this ones that we have here in the incident. So this is done. I'll remove the glass prism again, then join the lines. This is our emergent ray anyway. Then so that we can get the refracted ray. This is now a refracted ray. Can always remember to show your ray direction. So the next thing we do is to measure this angle that we have here. the angle we have there is about 19 degree. So now we have our refracted rate to be what? 19 degree. Is it 19 degree? Let me check very well. Wait, this is about 14 degree. How do I get that 19 one? Oh wow. That's about 14 degrees. 14 degree. 14 degrees what we have there. Said 19. So we are done with that. So I'm going to bring up the table, already existing one that we have, to make up, so that will not take much time. So based on that, we have our what we have here is, for sine R we have 20 degree, we have 14 degree here. Then for 30 degree we have 19 degree. For 40 degree we have 29 degree. For 50 we have 31 degree. For 60 we have 37 degree. So we're going to be looking for the sines. Sine I, this should be sine I, and then sine R. So sine 20 will give us 0.342. Sine 14 will give us 0.212. Let's just say that. Sine 30 should be about 0.500. Sine 19 is equal to 0.326. Sine 40 should be about 0.42. Sine 29 will give us 0.485. Sine 50 will give us 0.76, let's say 766. Sine 31 will give us 0.515. Then sine 60 will give us 0.8866. Sine 30, this is sine 37. Is it 37? Okay. 37 we have 0.602. Now this is what we have in our already done experiment. So the next one we're going to be doing is to plot the graph. In plotting the graph, now I'll show you something about this graph that we have here. In this graph, this kind of graph graph paper we have, or graph book, what we use here, from this block, from this end, from this big one to that one is 2 cm, because we have 1 2 3 4 5 6 7 8 9 10 to get there. We say is what, 2 cm, but there are some other one you count 1 2 3 4 5, then you get your what, the thick line, the second thick line. That one is the one we say is what, 1 cm. So in this case, we're going to be looking at, before we plot this graph, it's always nice to choose the values that has to do with multiples of 5 or multiples of 2. It's very easy to work with than when you take any other ones. So now we're going to be looking at this. So from what we have, look at the highest value. The highest values we have here in the sine axis is what, 0.3, and the lowest is 0.3, and the highest is what, 0.8. So what we are going to do, since the sine, so from our graph, having established the fact that this, from this point to that one is what, 0.1, which is giving us, what is giving us here is 2 cm to what, 1 unit in the vertical axis, that is sine, in sine I. That means I said 2 cm towards 0.1 units. You always remember to write it down. So that's what we have there. Now the other side of it, when we look from here, from this point again, from this point to this point, another 2 cm in the horizontal axis. Now we are trying to establish the scale of what, sine R. This is our sine R. We're establishing the scale now. From here to here is 2 cm, giving us another 0.1. Giving us another 0.1. What we're doing now, just to establish this side, the sine R. In the sine R, the same scale. It seems that we are going to be using the same scale here. This is from here to here is 2 cm. Then we can say that this one is 0.1, which means 2 cm to what, 0.1 units. Then here we have what, 0.2. This other one is 0.3. 0.3, we say 0.4 here. This one is 0.5. We say was 0.6. This is 0.7. We say this one is was 0.8. Now our highest value in sine R axis, if you can see very well, find out our highest value is 0.6, and the lowest value is was 0.2, as you can see here. So now we have been able to establish the scales of both axes. So the next thing we are going to do is to plot the graph itself. So in order to plot it, what we are going to do here, remember the first one we have in sine R, we have 0.34 approximately. We're going to be rounding it up. So we have 0.34 approximately. So we use that because our scale can only access 2 decimal places. So now what we do here is we start from here. We locate 0.3. This will be 0. This is 0.2. Here now between 0.4 and 0.2 we have another thick line, that is 0.3. 0.3 now. Then we locate the point where we have 0.34. 0.34 will then be 1 2 3 4. I'm counting the small line in between them, in between 0.3 and 0.4. Now what I have here, I have 4 there. That will give us was 0.34. So now we have 0.34. We're going to locate where we have 0.2 in sine axis. 0.2 in sine axis. In sine R axis. Now what do? We go by here. We have 0.2 here. Look at our 0.2. Now 0.2, we have it. This is 0.2. Now we look for 0.42. If here is, let's just move this to 2 here. If here is 2, 0.2, then we count again 1, 2, 3, 4. This is where we have it. We'll mark it. That's how to plot your graph. So the next one, we have in sine axis, we have 0 0.5, 0.5, 0.5. Sine I axis, that is 0.5 will be here between 4 and 0.4 and 0.6. We have 0.5. Then the other one is 0.33. 0.33. We have 3 here. This is 3. This is 5. This space is 3. Then this 3 now. This is 5. The point of intersection is here. We said that the 3 is what? 0.33. We count again. 1, 2, 3. Stop here. So that's the next one. So the next one we have there is 0.64. 0.64 in sine I axis. 0.6. This is 0.6. 0.6. Then the other one 0.49. 0.49. This is 4. Let's locate the 6 first in the vertical axis. 0.6 is here. So we count 0.64. 1, 2, 3, 4. We stop here. Now that's the next one. So no, the other one is 0. It's not supposed to be there. You need to locate 0.49. Not supposed to be there. So we have 0.4 here. We then locate 0.49. What we have is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is our 9. Where we'll stop. So the next one is 0. In the sine I axis, we have 0.77. 0.77. This is our 7 here. This is our 7. In between 0.6 and 0.8, we have our 7 here. We'll locate it. Then we have under the sine, on sine R axis, we have 0.52. This is 0.52. I use my ruler to track it. This is 0.52. Now this is 0.7. Then we say 7, 7. We count 1, 2, 3, 4, 5, 6, 7. This is where we have it. Then the other one is 0.52. Since here is our 7, we have 0.5 already. I'm already 0.5 here. Count 1, 2. I will place it there. Here now. So this is the next one. So the last one, we have 0.87. 0.87 in the sine I axis. 0.87. This is all this area. From here is 8. So we look for the other one. 6. 0.6 is what we are going to stop approximately. 0.6 is here. With my ruler, I'm locating it. So this other one is 0.8. What? 7. This is 0.6. 1, 2, 3, 4, 5, 6, 7. Stop here. Then this is what I have. So we're going to be joining the points. If we join the points, now we just join the point. You find out that only one point is out of the line, out of the straight line here. We can see that one is the other one is almost out, but not completely. Very close to the line. So now what we do now is to get the slope. To get the slope, what we do is now to take the slope. Now what I can do is to do what? Then I pick from here. I can pick any part, any side I want. But it's always nice to make it a bit big. You understand? So I'm taking from this point. So remember, for slope is always change equal to change in sine I over what? Change in sine R. So now we're going to be locating the changes. Let's look at the other one from here. From this point, what we have is about 0 point. This is 1. This is 1. We have this is 0.1. We have 0.1234. That is, you can say 4. You can say 4. 0.1234. We can say 4 now. 0. We say is what? The lowest value there is what? 0.14. So the other one, we have this place. The highest value is 0.6, 0.6. Now equal to, what do we have here? The sign. Under the sign we have sine I. We have this point is the lowest value there, 0.2, 0.2. Then the highest value we have here is about 0. This is 8. This is 0.88. 0.88. That's what we have. So in that case, let's subtract them. That is 0.88 minus 0.2, and the over 1, 0.6 minus 0.14. So we subtract the first one, 0.88 minus 0.2. What we have is what? It will give us 0.68 all over the lower one. That is 0.5, 0.6 minus 0.414. We have 0.46. So when we divide the 0.68 divided by, what we have is what? Equal to 1.48 approximately. This is 1.48. Now refractive index we are looking for, if we make it approximately to 1 decimal point, we have what? 1.5. That is what we have. Thank you so much for being part of this class, and I want to encourage you, if you are joining us for the first time, subscribe so that you always get more from us, and then like and share. If you have any question, you can leave it in the comment section. We will always attend to you. Thank you so much.